Welcome to part 2 of lesson 6.5, solving square root and other radical equations. In this lesson, we're going to work with how to solve the problems when you have a variable on both sides of the equation. The first thing we want to do is isolate the radical. I'm just going to use the radical sign. So I'm going to subtract the 3 from both sides. I have the square root 5x minus 1 equal to x minus 3. Just as before, I'm going to square the square root and do it to both sides. By doing that, I square this and it cancels out the radical. So I have 5x minus 1. And then I have to square the right-hand side. When you do this, it is not x squared plus 9. When you square a binomial, that means the entire binomial occurs twice. Which leads us to FOIL. After you FOIL, you get x squared. There's minus 3x and minus 3x, which is minus 6x. And negative 3 times negative 3 is positive 9. If you simply square the x and the 3, you miss out on that middle term. So you have to FOIL the binomial. Now I need to get everything to one side of the equation. I want to set it equal to 0. Keep the x squared positive, so I'm going to move everything over to the right-hand side. Subtract the 5x and add the 1. That gives me 0 equal to x squared minus 11x plus 10. At this point, to solve the equation, I need to factor. Well, it multiplies to give me a positive 10 and adds to give me negative 11. My factors are negative 10 and negative 1. Put them into parentheses, x minus 10 and x minus 1 equals 0. I'm going to set each group of parentheses equal to 0 and solve for x. So x minus 10 equals 0 and x minus 1, equals 0. Add the 10 over, x equals 10. Add the 1, x equals 1. And there's one last thing we need to do on these problems. We need to check for extraneous solutions. I need to plug each one of these back into the original equation. Right? Whenever I FOILed something, I created a second answer, and I need to make sure that both of those answers work. I went back and I checked both with the x equals 10 and x equals 1. When I plugged 10 in, showing all my work, I got that the solution worked out. When I plugged the 1 in, showing my work here, I got 2 plus 3, which is 5, and does not equal 1. So x equals 1 did not work out, and my solution is x equals 10. On these problems, we need to check for extraneous solutions. Sometimes both answers will work out, sometimes only one answer will work out. All right, let's get number 8 started. Similar to number 7, I want to isolate the radical or isolate the exponent. So I'm going to add the x to the other side, giving me 5x minus 4 to the 1/2 power is equal to x. I'm going to multiply by the reciprocal of the power. So this is going to be 1/2, which is squared. The 2's cancel, leaving me with 5x minus 4. This is not x times 2, but this is x squared. So in this problem, there's nothing I need to FOIL. At this point, I can set it equal to 0. I'm going to move everything to the side of the x squared. So subtract the 5x and add the 4. So I need to factor x squared minus 5x plus 4. What multiplies to give me 4 and adds to give me 5x? Negative 5x. Well, that'll be negative 4 and negative 1. Put them into parentheses, x minus 4 and x minus 1. Set each group of parentheses equal to 0. X minus 4 equal to 0 leaves me with x equals 4. And x minus 1 equals 0 leaves me with x equals 1. I need to go back now and check my solutions with my original problem. This is my checked solutions. I plugged when x equals 4 into my original equation. Showing my work, at this point I went from an exponent of 1/2 and changed it to a square root. Square root of 16 was 4, which worked out to be 0. Doing the same thing with x equals 1. I plugged 1 in, changed it to a square root. I got 1 minus 1 equals 0. Both of them worked out. This time both were my solutions. All right, we have one more problem to go through. Number 9. What do I do when I've got exponents, two sets of exponents on the same side of the equation? Right. I am going to add the exponent to the other side. I want to isolate one set of exponents. So let's add that 2x plus 7 to the 1/2 power. So I get 3x plus 2 to the 1/2 is equal to 2x plus 7 to the 1/2 power. Now, when I multiply by the reciprocal of the power, the reciprocal of 1/2 is 2. The 2's cancel, leaving me with 3x plus 2. And I have to do it to both sides of the equation, and both exponents cancel out. So we really like it when you've got the same exponent on both sides of the equation. Now I can solve 3x plus 2 equals 2x minus 7. I'm going to subtract the 2x. I'm going to subtract the 2, which gives me 3 minus 2 is x. 7 minus 2 is 5. I have one solution, so I don't really have to check for extraneous solutions because there are no extra solutions that came up. And this concludes part 2 of the lesson. Thanks for listening.